dreams are not what you see while sleeping. Dreams are which do not let you sleep at night. Let's have the dream. Chase the dream. Let's talk about the new concept. Composition of two Shm in the same direction. Two forces are acting on the particle. One force produces simple harmonic motion. Second force also produces simple harmonic motion. Let's have the two equations of simple harmonic motions. The first equation is x1 is equal to a1 sine omega t. Call it equation number 1. Two forces acting on the particle produces simple harmonic motions. First force produces simple harmonic motion. Second force also produces simple harmonic motion. And the equations of simple harmonic motions, I am writing now the first equation, x1 is equal to a1 sine omega t. Call it equation number 1. This is the equation of simple harmonic motion. I am writing the second equation, x2 is equal to a2 sine omega t plus delta. Call it equation number 2. What I have done here, what I have written, two equations of SHFs. The first equation is x1 is equal to a1 sine omega t. I am writing the second equation, x2 is equal to a2 sine omega t plus delta. Here, amplitudes are different. They have the phase difference delta, but same frequency. They are having different amplitudes. They are having phase difference delta and same frequency. They are having same frequency. Let's have the resultant of two SHFs. X is equal to x1 plus x2. What I am doing here, I am adding these two equations. What I have written, two equations. The first equation, x1 is equal to a1 sine omega t. Second equation, I have written x2 is equal to a2 sine omega t plus delta, where a1, a2 are amplitudes. A1, a2 are amplitudes. Delta is the phase difference and n is the frequency. They have different amplitudes, phase difference delta, but they have the same frequency. Now we are adding these two equations. After addition, what we are getting, x is equal to x1 plus x2. I am writing here, instead of x1, a1 sine omega t plus a2 sine omega t plus delta. Simply, I have written these two equations and I am adding to these two equations, I am getting the resultant. X is equal to a1 sine omega t plus a2 sine omega t plus delta. Delta is called as phase difference. See, x is equal to a1 sine omega t as it is plus a2. Now we have to expand this bracket. Sine omega t cos delta plus sine delta cos omega t. Sin A plus B, sin A cos B, cos A sin B, sin omega t, cos omega t, sin A cos B, cos A sin B. This is the expansion, sin A instead of A omega t, sin B cos delta, sin A cos B, cos A sin B, cos A sin B, sin delta into cos omega t. X is equal to a1 sin omega t, a2 can be operated. Let's operate A2. A2 sin omega t cos delta plus A2 sin delta cos omega t. Now, what I am going to do, I am going to take the common sin omega t. See, look at board. This is the underlying part. I am going to take the common sin omega t. Let's see what happens. Sin omega t can be taken outside the bracket. What remains in the bracket? A1 plus A2 cos delta plus A2 sin delta cos omega t. See, I am getting this equation. What I have done? Simply I have taken the common sin omega t. The remaining part is kept in a rectangular box. A1 plus A2 cos delta as it is. The remaining part is written A2 sin delta cos omega t as it is. Let's assume, I am assuming this value A1 plus A2 cos delta is equal to C and A2 sin delta is equal to D. I have assumed this value A1 plus A2 cos delta. I have assumed C letter, capital C letter. A2 sin delta is equal to capital D letter. Let's put these values. The equation is going to become x is equal to sin omega t C plus D cos omega t. We are getting this equation. What equations we are getting? Sin omega t C plus D cos omega t. Now, I am going to do something arrangement here in this equation. Thus now, what I have done here, instead of this bracket, I have taken capital C. And instead of this A2 sin delta, I am going to take capital D. There is no effect on the equation. So the equation is going to become x is equal to sin omega t as it is. Instead of this bracket, what I have written, capital C plus, instead of A2 sin delta, what I have written here, the capital D cos omega t. I am going to do some arrangement. What arrangement I am going to do? See, look at both. X is equal to under root C square plus D square in bracket sin omega t C divided by under root C square plus D square plus cos omega t D upon under root C square plus D square bracket close. This is the arrangement. This is the new arrangement. What I have done here, I have made the arrangement. I am multiplying this factor under root C square plus D square. And this factor I have taken here in bracket in numerator, in denominator. In denominator. Get lost. There is no effect on this equation. There is no effect on this equation. I am multiplying this factor and dividing also. I have taken the common under root C square plus D square. Sin omega t C divided by under root C square plus D square. This get lost. Nothing is harmed. There is no effect on this equation. Cos omega t D divided by under root C square plus D square. Now, I am going to take, I am going to assume C upon under root plus d square. Assume. We have had the discussion up to this step. Let's assume. Assume. I am assuming one value c upon under root c square plus d square is equal to cos phi, and d upon under root c square plus d square is equal to sin phi. The equation is going to become x is equal to under root c square plus d square sin omega t cos phi plus cos omega t sin phi. X is equal to under root c square plus d square. This is the expansion of sin omega t plus phi. But this is nothing but amplitude. Instead of this, I may assume a under root c square plus d square. I may assume this is one amplitude. This is amplitude. I can assume under root c square plus d square a. You can use any letter, but I have used here a. X is equal to a sin omega t plus phi. This is the resultant of two SHMs having amplitude capital A and phase difference phi. You can